Imagine the sky suddenly darkening in the middle of the day or the moon turning a deep, glowing red at night. Most people think they already know the difference between solar and lunar eclipses, but the real story is far more dramatic and scientifically revealing. Today, we're diving into the true mechanics behind these cosmic alignments. Why solar eclipses demand almost impossible precision, why lunar eclipses paint the moon red, and what each event teaches us about the sun, Earth, and moon's delicate orbital dance. By the end of this video, you'll see eclipses not as sky events, but as stunning scientific breakthroughs. Solar and lunar eclipses don't happen by luck, they happen because of an incredibly precise three-body alignment that almost never occurs perfectly. And here's the twist. The moon's orbit isn't flat. It's tilted by about 5 degrees, which means most of the time, the moon passes above or below the sun from our viewpoint. That tilt alone explains why we don't get an eclipse every month. But when everything lines up just right, something special happens. A solar eclipse requires the moon to sit directly between the sun and Earth, and that alignment has to be exact down to fractions of a degree. The moon's shadow, called the umbra, is tiny. It hits only a narrow strip of Earth, sometimes just 150 kilometers wide. If you're outside that path, you miss it completely. A lunar eclipse works differently. The Earth's shadow is huge, big enough to swallow the entire moon. That's why half the planet can see it at once. And when the moon slides into Earth's umbra, sunlight bends through our atmosphere, filtering blue light and leaving only warm reds. That's the science behind the breathtaking blood moon. This geometry sets the stage for everything that follows. If you've ever wondered why solar eclipses feel like once-in-a-lifetime events while lunar eclipses seem more common, the answer lies in visibility. A total solar eclipse might last only a few minutes for people standing in the right location. Even then, they must be exactly inside the narrow path of totality. Step just a few kilometers away, and you see only a partial eclipse or nothing dramatic at all. Lunar eclipses are the complete opposite. Because Earth's shadow is massive, anyone on the night side of the planet can watch the moon fade into darkness. And the show lasts longer, sometimes up to 3 hours, giving millions of people across continents a front-row seat. This difference affects history too. Ancient records show civilizations predicting lunar eclipses far earlier than solar ones because they were easier to observe and track. Modern science still uses this visibility advantage. Lunar eclipses help researchers study the composition of Earth's upper atmosphere as refracted sunlight passes through it. Meanwhile, solar eclipses, though rarer, are priceless for scientists. They expose features of the sun's outer atmosphere that are usually invisible due to intense sunlight. In short, one event is global, the other intimate, and that contrast shapes their scientific value. Beyond the beauty, eclipses are scientific gold mines that reveal details about our planet and its neighbors. During a total solar eclipse, the sun's corona, normally hidden, becomes visible. Scientists use that precious window to study solar winds, magnetic fields, and the structure of the sun's outer atmosphere. Even today, some coronal mysteries can only be studied during these rare alignments. Lunar eclipses unlock different secrets. When Earth casts its shadow on the moon, the curved edge of that shadow demonstrates without telescopes that Earth is round. But even more impressive, the reddish glow on the moon helps scientists measure the state of Earth's atmosphere. Dust storms, volcanic eruptions, and pollution levels can change the tone of the moon's red hue. In fact, major eruptions have caused unusually dark eclipses because the atmosphere was filled with ash. Eclipses also help track the long-term evolution of the Earth-Moon relationship. By studying eclipse timings going back centuries, scientists confirmed that the moon is slowly drifting away about 3.8 centimeters per year. This tiny motion shapes future eclipse predictions and even Earth's rotation. So while eclipses captivate the public, they quietly deliver crucial data that deepens our understanding of the sun, Earth, and moon. Solar and lunar eclipses are more than sky spectacles, they're windows into the mechanics of our solar system. Solar eclipses reveal the sun's hidden outer layers. Lunar eclipses teach us about Earth's atmosphere and the changing Earth-Moon distance. Together, they show how perfectly balanced our cosmic neighborhood truly is. If you enjoyed learning the deeper science behind eclipses, make sure to explore our other episodes where we break down complex space topics in the most exciting way. Don't forget to like, share, and subscribe and join us for more journeys into the wonders above.